Okay, we're back on section 3 of feature geometry. And in the last section of this handout, we looked at some of the evidence for the major place node, and we saw a bunch of different processes that served as evidence for that place node. But then also we looked at the general form of evidence within feature geometry theory. Right? How do we get evidence about which kinds of things in the phonology do or don't constitute featural constituents or nodes in the feature geometry. And we saw that there's a couple different things that go into that. So first of all, we talked about the phonetic or the functional unity of a set of features, right? So coronal, labial, dorsal, these all go into defining the physical place at which a constriction is located, right? So there's some general coherence to that bundle of features. But the final test, and the one we're going to be using as the main criterion here, is whether those bundles of features pattern together in phonological phenomena. Right? So in general, in autosegmental theory, there's three kinds of basic phenomena we've looked at: spreading, delinking, and OCP effects. And the idea of feature geometry is that if you have a set of features like labial, coronal, and dorsal that form a featural constituent, we should see that bundle of features reflected by each of these three phenomena. They ought to do all of these things, right? So this is based in part on the paper by John McCarthy that's on the website here from the 1980s. Here's what he says. The character of our theory is such that each operation and constraint is predicted to operate on each class node of the feature geometry in some reasonably well-attested linguistic phenomenon. In other words, we should be able to freely combine the predicates of our theory of representations and our theory of operations and constraints, and in each case come up with some real rule that languages have. Right? So we saw that above for the major place features, for labial, coronal, and dorsal all patterning together. We saw that there are spreading phenomena, which is just place assimilation, delinking phenomena, which is debuccalization, and we saw a couple OCP place examples. So in particular, the Arabic example that we looked at a few weeks ago was an example of a constraint on consonants having the same place within a root. Right? So now we're going to do the same for other sets of features. And the first set here is basically all the features together, right? So the tree, this constituent tree of features, is going to need to have a top node or a root node. And that's basically the structural instantiation of a single segment. Well, what does that mean? It means that sometimes all the features of an entire segment seem to pattern together. That's why we have the notion segment in the first place. In the feature geometry, that's because all the features in a segment are going to be dominated by this one single node in the feature geometry, and then we'll work our way down the tree and look at smaller nodes underneath here. But what would it look like if all the features in an entire segment were spreading? It would look like total assimilation. So the example here is from Italian. And what we're looking at here in Italian is a couple of prefixes, and there's several prefixes that behave this way in Italian. And in fact, some of these Latinate prefixes have also made their way into English, although the phonetics of English is very different, so this argument doesn't work the same in English. But in Italian, it really works because we have consonant length, and we can see where consonants have doubled. In English, these tend to double in the spelling, but not actually in the phonology, right? Not in the pronunciation. In Italian, they double in pronunciation as well. What's going on here? Well, let's take a look at these prefixes and attach them to a variety of different stems and see how this comes out. So you might want to take a minute now and just pause and try to figure out for these prefixes why I've written them the way I have with these underlying representations instead of some other ones, and what happens when they get put in different contexts. So take a minute and look at that. Okay, if you're done, here's what we're seeing in this Italian data. Both of these prefixes are written here as beginning with, as ending with coronal nasals underlyingly. So underlying representations in and con. And how do we know that? Well, here, the vowel initial stems that they're attaching to, these are working as the test cases, right? So they surface faithfully before vowels. You take the word applicabile, which means reachable in Italian. You put this not in prefix before it, and that n comes out as a n, inapplicabile. Similarly, urbazione, conurbazione. which is like the gathering of settlements, right, or a collection of houses or something like that. But when you put these prefixes before a sonorant consonant instead, you get something different here, which is total assimilation, right? So before a lateral liquid, this final consonant turns into a lateral liquid, and you get a geminate lateral liquid. So in plus legale becomes illegale with a long or geminate l. Similarly with a nasal here, if you take this prefix and attach it to the stem morale, which means moral, you get immorale with a long nasal. This is another example with another prefix before a lateral liquid from legare, which I think means tie. You put this prefix on, you get collegare, to put together. So how is this going to work in the feature geometry? Well, here's what we have. We have a couple time slots. Each time slot is going to be associated with some segmental features in a root node. And each of these root nodes is going to dominate a whole bunch of other features. All of the features that define the segment n in this first case, that define the segment some other sonorant consonant. Let's make this a l just for the sake of argument here. In the second case, and I'm going to abbreviate these with IPA symbols. But what's really underneath these root nodes is the entire complex of features that make up, in that first case, a n, and in the second case, a lateral liquid l. So this is the input. You have a segment n, which is dominated by a root node, preceding, at this time slot level, a segment l with all the features of a l down here dominated by a root node. And when this is in coda position, it looks like, as the coda of a syllable, so we might want to put in a bracket here showing that the rule only applies in coda position. What happens is that this root node delinks, and that time slot gets filled in. Oh, excuse me, I did that wrong. Wrong lines. Okay. Sorry, trying that again. This root node spreads to link to the preceding time slot. Sorry, that is a messy dashed line. Let me try that one more time. Still working with the display software here. This is supposed to be a dashed line showing relinking of spreading rather of this root node to the preceding time slot. Now you have two time slots, both of which are filled by a single root node that dominates the features of a l. This root node that had all the features of the n attached to it has just been delinked and will be erased at the end of the phonology. So stray erasure. You end up with a long l, a l that occupies two time slots. Similarly for the m in this example, it's the exact same thing. So this is total assimilation. It's spreading of a root node. And we've seen this as well in Sardinian. So there was an example from the last unit where we looked at empty time slots in Sardinian, and we also found this total spreading, total assimilation kind of phenomenon there. So not uncommon. And this is taken to be, in the feature geometry, evidence for the existence of a single root node dominating all of the features of a segment, the fact that they can all pattern together in this assimilation process. So oftentimes when people abbreviate these, rather than putting in the root node and all the features underneath and whatever, they're just going to abbreviate these root nodes with IPA characters, because this essentially is what an entire segment is in feature geometry theory. It's the root node. So we'll see this in the examples that are taken from other sources here. They're just going to use IPA characters to stand in for an entire root node. So that was the spreading of a root node, was total assimilation. Delinking of a root node, what would that look like? Well, it's going to be basically segment deletion. except the way we're going to be able to tell that it's a root node being deleted and not a timing slot is that we're going to get compensatory lengthening. Right? So here's an example from ancient Attic Greek. If you conjugate verbs in a particular way, and I don't even remember which of these is the stem and which one of them is the inflection, but this is the inflected form for I am. What happens here is that you can't have this s-m cluster in ancient Attic Greek, and so the s features delink. So these are root nodes, these IPA characters here. They're associated with moras that are inside a syllable. This is basically the time slots associated with them. And what happens here? Well, the root node is delinked from its time slot here because you can't have a s in coda position preceding this m segment. And then after that root node has been delinked, the time slot associated with it relinks to the preceding vowel. You end up with a long vowel here, a me, I am, uh, even though the input was from es and me. Interestingly, there's another variety of ancient Greek, lesbian Greek, where instead of the preceding vowel taking over that time slot, the features of the following nasal actually take over the time slot. So it would look just like this, except this mora has been relinked over to the following uh, nasal rather than the preceding vowel. So there's a variety of different kinds of compensatory lengthening that you get in these situations, but all of them involve deletion of all the features associated with a segment, but preservation of the time slot associated with that segment. Right? Another example that we looked at earlier in this class was in Turkish, where something very, very similar happened, except that it was optional in Turkish or variable. So that's delinking of an entire root node, is deletion with compensatory lengthening. And finally, for the OCP, what does it look like when you have, you're not allowed to have two adjacent identical root nodes? Well, what this should look like is that if you have two adjacent identical segments, then they better be doubly linked to a single root node rather than two separate root nodes, which is what the OCP would ban. So if you recall our OCP discussion from all those weeks ago, the OCP doesn't say that you can't have two of the same thing in a row on the surface. It just says that if you do, those better be multiple instantiations of the same autosegment or multiple links to the same autosegment rather than adjacent identical autosegments. So evidence that this is so comes from languages that have geminates where you can't put anything in the middle of those geminates. So this is referred to in general as geminate inalterability, and it's present in just about every language that has geminate consonants. It is the case that you can't split up those geminate consonants, for instance, by vowel epenthesis. Right? So Shine and Stereotti in the 1980s go through a dozen or so languages with epenthesis and geminate consonants and show that the epenthesis never splits up a geminate, right? So you can't have this state of affairs where you have two time slots associated with the same root node here. So this, again, the IPA symbols are standing in for root nodes, and you insert a new segment in between those two time slots, because if you did that, it would cross lines here. You'd have a violation of the line crossing prohibition, which is taken to be universally impossible. This is why you can't split up a geminate with epenthesis. That's the basic idea. Now, if these geminates were just allowed to be two adjacent identical root nodes, then there'd be no problem doing this. You'd have 1, 2, 3 lines and 1, 2, 3 root nodes, and there'd be no problem with it. So the fact that you can't do this is itself evidence for the idea that in cases like this, the two time slots are really both associated with a single root node. Or in other words, there is an obligatory contour principle for entire segments, right? So geminate segments here are taken to be multiple time slots linked to the same root node rather than adjacent identical root nodes. We also saw this in Arabic verb inflection earlier in the class when we were doing the OCP example. We had a couple examples where so-called biliteral roots in Arabic, which are roots that have only two consonants in them, you get two slots in their templatic morphology filled in by the same consonant. And when you do inflection on those particular stems, those geminates can't be split by the templatic vowels from inflection. So it was slightly more complicated, but that's the same basic idea. Right? So that's the idea. The root node exists. How do we know that? Well, we find root node spreading, which is total assimilation. We find root node deletion, which is basically segment deletion, but with compensatory lengthening. And we find OCP effects on entire root nodes, namely geminate inalterability. So that's all three things we mentioned for the root node, spreading, delinking, and OCP effects. Now, the root node itself, interestingly, I've just been writing it as RT, and these people have been writing it as IPA symbols, but actually, there's pretty good evidence that that root node itself has some featural content. So McCarthy suggests that the root node has at least the features sonorant and consonantal inside it. So why do we think that? Well, the idea is that the presence of these features in any phonological generalization implies the presence of all other features in that generalization. So these features, sonorant and consonant, the claim is, they never pattern by themselves. They always go with all the other features in a segment. And so we can capture that by saying that, well, these are the root node. And if they do anything, then everything underneath them has to do it as well. That's why they never operate by themselves. So the idea here is that sonorant and consonantal never spread except with all other features. So we don't have any language that shows sonorant harmony within a word or consonant harmony where all the sounds have to be consonants or non-consonants or something like that. Um, so when these features spread, and they do spread in examples like this in the Italian total assimilation case, but they take all the other features with them because they are at the top of the feature geometry tree and they can't spread without everything else spreading. So again, if inside this RT section here we actually have plus consonantal plus sonorant, right? That's going to spread to the preceding time slot, but it's going to take everything else underneath it as well. So plus coronal, plus lateral, plus voiced, whatever other features you have here. McCarthy also says that because all other features are dependents of these major class features, that's what he calls these two features, we could make no feature distinctions at all if the major class features weren't specified. So the idea here is that in lexical entries, if you're going to specify some feature in the feature geometry tree, then everything above it in the tree also has to be specified. And so if you don't specify consonantal or sonorant, then you won't be able to make lexical contrasts for any other features, right? So the idea here is that all languages then have distinctions for consonantal and sonorant, right? So every language has a contrast between at least one sonorant consonant and at least one obstruent consonant. Between consonants and vowels or consonants and glides and so on and so forth. Whereas not all languages have contrasts for every other feature. So compare this to other manner features in particular. There are languages that don't have any minimal contrasts for the feature nasal, for instance, which is another major class feature, but not one in the root node. Yeah, there's a number of American Indian languages that have no nasals at all. I think Mohawk is one of them. And there's languages that have no minimal contrast for continuancy either. So almost the entire Pama-Nyungan family of languages spoken in Australia has no contrast for continuancy. They have stops, but no fricatives in their obstruent systems. And so there are no minimal contrasts for these features. And that's possible because these features, nasal and continuant, are down somewhere else in the feature geometry tree. They're not part of the root node. But if you didn't have contrast for consonantal or sonorant, right, then you wouldn't have anything else underneath the root node and you just wouldn't have any contrasts at all. So that's another argument for the root node, for what's in the root node from the perspective of feature geometry. So that's the basic idea. Sonorant and consonantal are up there at the top of the feature tree. And they dominate all the other features, including the major place node, which we looked at earlier, and we'll see evidence for several more nodes later on. And at the end, I'll show you a sort of final tree of the entire feature geometry theory that we're working on in here. Okay, here's another major node here that's going to be underneath the root node, but separate from, say, the major place node. And this one is going to be referred to as the laryngeal node. And this has all the features related to the glottis. So within the context of this McCarthy paper, he mentions several different features here. These are going to be similar to the ones we've been using in class. We have features like voicing. Obviously, this is the one that we've looked at the most. So voiced versus voiceless consonants. Also constricted glottis, where segments like ejectives and glottal stops are going to be plus constricted glottis, and also spread glottis. So segments like h, the glottal fricative, and all aspirated stops are going to be spread glottis. And so the claim here is that all of these features pattern together in the phonology as well. How does that work? Well, for spreading, evidence for the laryngeal node comes from laryngeal assimilation. And we've seen a number of examples of this in class, although mostly we've seen this in languages with just a voicing distinction, where you get voicing assimilation for that one feature. Here we want to look for evidence that voicing and one or more of the other laryngeal features all pattern together. And so again, we're going to go back to classical Greek here, which has a three-way laryngeal contrast between voiced, plain voiceless, and aspirated voiceless stops. Right? And so there's going to be at least two laryngeal features here, spread glottis and voicing. And when you get assimilation between adjacent consonants in classical Greek, both of these features assimilate to following obstruents. Right? So we can see, for instance, this verb form I write has the root grap with a aspirated stop, followed by the suffix o, so grapho. If you take this same stem, grap, and put it before a voiceless unaspirated stop, as in this form has been written, you get assimilation of that underlyingly aspirated stop to the following unaspirated one, gegraptai. And if you take the same stem here, grap, right, and you put it before this, I guess, gerundive suffix that begins with a voiced stop, you get, again, assimilation of both voicing and non-aspiration to the following consonant. So grabden. You can't have combinations like aspirated followed by plain or aspirated followed by voiced. And we can see that because this stem alternates. It takes on the value for laryngeal features of whatever follows it. So the claim here is that we're going to have, again, sorry, trying to get my text in place here. We're going to have a time slot here, time slot here, and each of these is going to have some set of laryngeal features. So somewhere down in their feature geometry, there's going to be a node here with at least voicing and spread glottis in it. So I'm going to call this node LAR. And that's going to dominate all of the laryngeal features. So for instance, in the case of duh, this is going to be plus voice, and minus spread glottis. For the underlying pa in that verb to write, we're going to be minus voice. I'm going to abbreviate that V here because I'm running out of space, and plus spread glottis. And what's happening here? Well, again, in preconsonantal or pre-obstruent position, what we're getting is a delinking of this laryngeal node. So the root node survives. Everything else about this survives, but just the laryngeal node is delinking. and that time slot is relinking to the following laryngeal node. So it's the entire laryngeal node that's being spread from this time slot back to the preceding segment. You end up with two segments in a row that have different root nodes, which I haven't written in here. So they have different other kinds of features, but their laryngeal features are shared. They're both going to be plus voice and minus spread glottis. That is, they're both going to be voiced and unaspirated. Right? So this is how um, laryngeal node works. I should probably actually just put into the tree here to make it clear how this works, that it's not the entire segmental complex that's spreading here. There's also going to be a root node up here that doesn't spread. So let's try that. Okay, so two root nodes. They're each going to be linked to laryngeal nodes as well as a bunch of other stuff. There's going to be a bunch of other features over here linked to each of these, including place of articulation and whatever else these segments have. What's happening here is just the laryngeal node spreading from one to the next. Excuse me, spreading from one to the preceding one. This is the basic idea. What about delinking? Well, similarly, looking at a language with more than minimal laryngeal contrast, so feature with three-way laryngeal contrasts, we can see that when one of these features delinks, they all delink. So this is going to be laryngeal neutralization in Thai. And we saw this earlier in the class, actually last semester, when we looked at voicing contrast. We saw that Thai has a three-way contrast in onset position or before a vowel anyway, where you get voiceless unaspirated, voiceless unaspirated, voiceless aspirated, and voiced unaspirated stops, just like in classical Greek. And these are meaning bearing. These are minimal distinctions that distinguish between the meanings of words, as you can see here. But in coda position or in non prevocalic position, like at the end of a word, you get only the plain unaspirated series, and you can't have word final voice stops or word final aspirated stops. Right? So this is laryngeal neutralization. Going back up here, this is going to again rely on the notion of a laryngeal node. So I'm just going to get rid of this because it's not relevant to the delinking example. But what's going on here, if you have a segment at the end of a word in Thai, and it's got, you know, its features, it's got a root node. In this case, if we were looking at a ba, it would have a root node with plus consonantal and minus sonorant, and then somewhere over here there'd be plus labial and minus cornal and whatever else. Down here, there's going to be the laryngeal node, which in this case is plus voice and minus spread glottis. This would be the case of underlying sebe if it ever existed. In word final position in Thai, that entire laryngeal node with all of its dependent features delinks and it receives whatever the default or unmarked realization is. With regard to voicing of stops, or laryngeal features of stops, arguably in every language, the unmarked features or the default features for a stop that isn't specified are going to be voiceless unaspirated. And that's what we find in Thai here. So that's spreading of laryngeal nodes, this assimilation process, delinking of laryngeal nodes, that's this neutralization process. What about OCP effects for laryngeal nodes? Well, McCarthy in this paper gives an example from Proto-Indo-European that I find pretty confusing and I don't find it very convincing. So you can look at that if you want. I'm going to skip it in the handout. Other things we've seen in here, we looked at Lyman's law in Japanese, which basically banned roots with more than one voiced obstruent in them in Japanese. So that could be seen as an OCP effect for, well, that would really only be for one feature rather than for the entire laryngeal node. Although in Japanese, because there only is voiced and voiceless obstruents, that would be the entire laryngeal node. There's various patterns involving more elaborate laryngeal systems in Chol and other Mayan languages that can be analyzed as OCP effects over laryngeal features, although they're not necessarily analyzed that way. And they get very complicated. So I'm going to sort of gloss over them here and say, well, let's be on the lookout for complex OCP phenomena involving more than one laryngeal feature. But for right now, we're going to skip over it. That said, we still have pretty good evidence for this laryngeal node. And then finally, there's going to be features that are below the root node. They're not contained in the root node, but they're not subject to any other large grouping. So we saw that laryngeal features are themselves a large grouping, and place of articulation features, major place features, are a large grouping. But it looks like features like nasal and continuant don't seem to be subject to any large subgroupings below the root node.